So the first part that we are going to create a FreeCAD model of is the crankshaft. You can see it in the left hand side isometric view on this slide. And if we just take a quick look at the crankshaft in isolation, on the left hand side here you can see an isometric view of the crankshaft. On the right hand side is a section view with dimensions. All the dimensions are given in millimeter, and you can see there are two holes running through the crankshaft, one with diameter 6 and one with a diameter 3. So I've already mentioned that we will use FreeCAD to create the CAD model of the crankshaft. The version of FreeCAD that I've got installed on my machine is 0.19.3. The current stable release of FreeCAD, and as you can see on the date here, it's March of 2022. So when you open FreeCAD, if you haven't changed the default, it will open in the start page, and the first thing we can do, we can actually close the start page and open the Spreadsheet Workbench. With the Spreadsheet Workbench open, we create an empty document and we double click the Create New Spreadsheet icon. You can either press the icon or go to Spreadsheet and click Create Spreadsheet. So in the model tree, here you can see the spreadsheet has been created, but it's not visible in the 3D view or in this right hand side view. So we need to double click on the spreadsheet and now it will appear. Okay, so you will notice in a minute why we open the spreadsheet. This is actually, I can give you the answer, it's because we want to parameterize the CAD model of the crankshaft. Okay, so just going back to this image over here, the first two parameters that we're going to define is the outer diameter of the crankshaft, this 24 millimeters, as well as the thickness or the depth of the crankshaft, this 15 millimeters. And you will see in a moment why those are the first features that we define. So we click on cell A1 and we can type the words outer diameter, enter, as well as the let's call it thickness. Okay, what we can do then in cell B next to outer diameter, we can type the value 24, and we know the thickness is 15 if I remember correctly. Okay, what we do now, we highlight these two cells with the values in. This is optional. If you want to do this, you can right click, click on properties, click display unit and type the letters mm for millimeter. Okay, so once we've typed in the values and the units, you can click on the cell, the stop cell, and we can assign an alias. This is compulsory. We have to do that because that's how we will link to the value in that cell. Okay, and the alias name can be exactly the same as the name we've typed here in cell A1. Just note that you are not allowed to type in any spaces. So we will type in outer diameter, no space, and press enter. Then we click on the thickness value cell, and there we will also say our alias is simply thickness. Okay, what we can do now, we can rename the spreadsheet. That we can do by right-clicking, type and click on rename, or the shortcut key is F2, and we can call that crank inputs. Right. Next, what we will do is we will save our file. At the moment it's still unnamed, so I just go File, Save As, and you can select any location obviously. Now the recommendation I can give you is to start with the name of the part. Okay, so this is the crank, and then add 6 digits to indicate the date. So this is the year 2022, and it's the 3rd month, and it's the 7th day. Okay, the reason why I like doing that is, if I can just show you quickly. So if I save another version of the crank on another date, it will obviously be an updated version, and so my files are organized alphabetically. So I have got all the cranks, all the versions of the crank underneath each other, and I can clearly see which is the latest version. If I save more than one version on the same day, I simply add a letter B, C, D, or whatever the case may be, to indicate a newer version of the file. Right, so the next thing that we want to do, you will notice here at the bottom, so we've got the 3D view, nothing has been created yet, and we've got the spreadsheet view. Now to see both views at the same time, we can go to Windows and we can type Tile. Now we've got the 3D view on the right and the spreadsheet on the left. The spreadsheet is active at the moment, that's why it's highlighted in blue. If I click on the 3D view, now the 3D view is active. Okay, and this is where we want to start now. We want to now actually create the model with these linked to these parameters. So what we do with the 3D view highlighted, okay, we've clicked there, we go to the part design workbench and we create a sketch. We can select the XY plane, you can select any other plane that you choose, but the XY plane for this application will work perfectly fine. So we click OK. Right, now for some reason the two windows changed sides, which is actually a good thing. It's not a problem, so it's actually a good thing. And you will notice that FreeCAD went into the Sketcher workbench because we are now going to create a sketch, which we've defined in the previous steps. So this sketch is very simple. We will create a circle by clicking on this white circle icon over here, and now we've got a choice of where we want to position the circle. Now it will make sense, and this is also a recommendation that I can make, to always center or try to center your sketches around the origin. It makes your models symmetric, it makes it easy to constrain, it also makes it easy to dimension. Okay, so with the circular create a circle clicked, we bring the mouse close to the origin of the sketch, and you will notice the minute you are close enough, that center red dot turns yellow, which means we are going to create our circle concentric with the origin, which is exactly what we want to do. Right, so it doesn't have to be exactly on the red dot. Close is good enough. The minute it turns yellow, or the moment it turns yellow, you can just click and drag and click. Alright, so now we've got a circle. it's unconstrained. There's still 1 degree of freedom. The specific degree of freedom, sorry, what I need to do, I need to press escape to go out of the circular, create a circle icon. Okay, if I now click, I can drag the circle, I can change the diameter. Alright, now what I want to do now is I want to click on the, not the radius, I want to select the Constrain Diameter icon. Okay, and that's because I've entered the diameter in my spreadsheet. Okay, so if I click now on the circle, this window pops up, and we click on the blue FX next to the value. If we click on that, we can type in the word crank inputs, and there you can see it. The minute I type the C, this pops up. So crank inputs dot, and the one I'm looking for is outer diameter. The minute I type a capital O, outer diameter appears, and there we go. And I can click OK. Okay, so with the crank diameter specified and dimensioned, linked to the parameter in the spreadsheet, we can close the sketch. The sketch is fully constrained. It says here so on the left hand side, so we can close that. And with the sketch highlighted, it's important that the sketch is highlighted as it is now. We can click on the pad option, and next to length we click on this FX icon again, and we start with C. There's crank inputs dot, okay, thickness, and there's thickness, and we can say okay. And obviously the thickness is supposed to be 15 millimeters, so we can just change that to the correct value. And what you can actually already see is the minute we change the parameter in the spreadsheet, we also change our 3D view, the model in the 3D view. We can also change that, for example, to 50. Yes, so it's as easy as that to link a parameter to your CAD file, CAD model. Right, so 24 and 15. And we can now save our model. Okay, so the next step will be, and we can say OK on the pad. So what you can also do is rename the body. The body is just a container in which all the features are stored in FreeCAD. So by highlighting body and we press F2, so we can now say, give it any name you like, body, for example, body crank. Okay, so with that done, we can once again save. Alright, so next we want to add these two holes. There's a center hole, there's an offset hole, and there's an offset. Okay, so those three parameters now need to be added to our spreadsheet. So there's a center hole with a value of 6. There's an offset hole with a value of 3, and there's the offset with a value of 8. Okay. Center hole diameter 6, this offset hole diameter 3, and the offset is 8. Okay, so we click again on the cell with the value, and here in Alias we just type the same word. You can use any word you like, but it makes sense to use the same name as given in cell A. So that's center hole. Okay, the next one, Alias, is offset hole. And the last one will be Alias offset. Okay, so now we click again in our 3D view. We can save it. Okay, let me just go back one step here where we've and obviously you can open any item in the model or tree view by double clicking on that item. Okay, and you will see the sketch is now part of the pad. The sketch that we've originally created, it is now a child or dependent on the pad. Okay, so the thing that I want to change here is I want to not just, let me just show this to you. The origin is obviously hidden, and I can show the origin. Okay, so if we look at the front view, the way we've padded it now, the sketch is on that plane, the sketch. I can show the sketch by selecting it and pressing spacebar. There you can see the sketch, and there you can see the pad. So what I suggest we do is, as I said earlier, let's keep everything symmetric to the origin. Now in order to do that, we can go back into the pad, and here are two options here at the bottom. Okay, the length is obviously stays the same, but if we click symmetric to the plane, then it pads or extrudes this sketch in both directions. You can also click reversed. That's also an option, but as I said, I like the idea of keeping everything symmetric to the origin, so the symmetric to the plane is a good option to click. So we say OK, we can hide the origin. Right, and what we do next is we will create, let me show the origin again. So in order to create these two holes, we can just simply create another sketch on the symmetry plane, create circles that will be pocketed into these holes that you see on the screen at the moment. Alright, so let me do that quickly. So we can select create a sketch again on the XY plane. That makes sense. You can select the plane here in the 3D view as well. Okay, so what we will do now, alright, over here is an icon in the Sketcher workbench that's very important if you work symmetrically as I've just suggested. What this does is, when in edit mode, switch between section view and full view. So what you see at the moment, we're looking at the sketch plane, but the sketch plane, there is 3D geometry between us and the sketch plane. Now if you click on this icon over here, then we're looking at it we're looking at the 3D geometry in section view, so what you see in front of you now is the sketch plane and the 3D geometry that's behind the sketch plane. You don't see the 3D geometry that's between you and the sketch plane anymore, and that's because we've clicked this icon over here. Right. And that's exactly what we want to do, because it's important that our center hole is concentric with the outer diameter. Okay, so we click again on create a circle. We bring it to the origin. The origin turns yellow. We click, we drag, we click. That's our center hole. Let us, while we are inside create a circle mode, we might as well create the circle for the offset hole. And now we have an option. We have a choice to make. We can create the center hole tangent to any of these 4 lines. Okay, and it doesn't matter. Okay, so I will just, let us select the y-axis, or the y-axis. You will see that the axis turns yellow as I approach it. When I now click, I know that my center line of the circle will be coincident with the line, with the y-axis. I drag it out, I click again, and there I have my 2 circles. And here you can see it is the fixed point to an object constraint is active. I call it tangent or coincident. It's not really coincident, it's more tangent to the line that we've selected. Okay, so there are our 2 circles. We've got 3 degrees of freedom. Okay, so if I just right click, I can move this circle up and down. I cannot move it away from the line or axis. I can change the diameter of this circle, and I can change the diameter of this circle. Those are the 3 degrees of freedom that we have. Okay. Now, okay, so what we do now is we need to link to the parameters of our spreadsheet. Okay, and the way we will do that is we will click on fix the diameter of a circle or arc. Okay, we'll click the center hole. We click the blue FX. We type in the letter C. There is the name of our spreadsheet, crank inputs, and what we want is center hole. And we say OK. We click OK, and there we go. Our center hole is constrained. Once again, we do exactly the same for the offset hole. So we click on the fix the diameter of a circle or arc. We click on the offset circle or offset hole. We click on the blue FX. We type the letter C. There's the name of our spreadsheet, crank inputs. And we type the letter O, we want offset hole, and we click OK and OK, and there you go. Both those circles are now constrained in diameter. We only have 1 degree of freedom left, and that's the offset. Okay, so for the offset we have a few options. Okay, we can either fix a length of a line or the distance between a line and a vertex, or in this case we can say fix the vertical distance between 2 points or line ends. Okay, and the reason why we can fix the vertical distance is because the offset hole is above the center hole. Right, so let me click that. I click the center hole, the offset hole rather. I click the origin. If I zoom in a little bit, there you go. You can immediately see my sketch change to green. It's fully constrained. Okay, and what I do is I click on the FX, the blue FX. I type the name of the letter C. I obtain the name of my spreadsheet, and I type the capital letter O. And what I'm looking for is offset. The result is 8 millimeters. It's exactly what we want, and we can enter that. let me just click OK, and there you go. Now you will see fully constrained sketch. You can position these dimensions as you see fit. Okay, it doesn't change anything to the sketch. It's just for visual representation. We can close our sketch, and what we do now is we click on this icon over here, create a pocket with a selected sketch. Note, we don't click create a hole with a sketch. We click create a pocket with a sketch. Right, holes are used when we use tapped holes or drilled holes, where the drilled hole is a blind hole, and so the tip of your drilled hole is important, the end of it, the bottom end. That's where you use holes or tapped holes. But for all through holes, we create our sketch, we dimension it as shown, and we click create a pocket with a selected sketch. Okay, and once again there's length, and we can just say, well, here you've got an option. So you can say it's important in terms of the type. In terms of the type, you have an option. You can just type through all, but it's important once again to click symmetric to the plane, because now it's going through all in both directions. And there you go. There is our CAD model of the crankshaft. We click OK. We can hide the origin by highlighting the origin and pressing the space tab. And let's see if this works. So if we change the center hole to something like 8, there you go, it updates immediately. If we change the offset hole to something like 1, it also changes. And if we change the offset to something like 10, it also updates. Alright, so everything works as advertised. Let's just update it again to 6. The offset hole was 3 millimeters and the offset was 8. There you go. Okay, so we can save. Thank you very much for watching.